Here's problem number 19 from section 7.2. Let's take a look at the graph, and so we can write the integral expression which represents the area between this curve and y equals 0, which is better known as the x-axis. When I look at this curve, I see a root at x equals 0, because 0 times whatever is going to give me 0. So I'm going to put a root there. Also, there's going to be a root when x is equal to a, because a squared minus a squared is 0. Likewise, there's going to be a root at negative a. It's going to be positive here, it's going to be negative here, and so there is my graph. Let me draw a typical rectangle here. Typical rectangle here. Seems like I have really two problems. One of them, in this area, the top curve is y equals 0. So the integral from negative a to 0, where the top curve is y equals 0, and the bottom curve is x square root a squared minus x squared dx. And of course dx, because the width of those rectangles are measured horizontally. Plus the integral from 0 to a, in which the top curve is x times root a squared minus x squared subtracted by 0 dx. So there we have our setup for the area. Now let's attack that integral. If I can do a little bit of cleanup here, I'm going to write this integral first. And when I take the 0 and this negative sign into account, I get the negative of, from a to 0, of x square root a squared minus x squared dx. Right? Now, since these are essentially the same integrals, I'm going to take their antiderivatives only once, and that looks like this. The integral of x square root a squared minus x squared dx uses the u substitution a squared minus x squared, which means that du is equal to negative 2x dx, or negative 1/2 du is equal to x dx. When I do that, I get negative 1/2 u to the 1/2 du, or negative 1/2 times 2/3 x to the 3/2 plus, u to the 3/2 plus c. These twos cancel, and I end up getting negative 1/3 u, which is a squared minus x squared to the 3/2 plus c. Which means if I take that information, I get 1/3 times a squared minus x squared to the 3/2 evaluated from 0 to a, minus a minus 1/3 a squared minus x squared to the 3/2 evaluated from negative a to 0. Plugging in, I get negative 1/3. When I plug in a, the upper bound, I get a squared minus x squared, which is 0. When I plug in 0, I get a squared minus 0, which is, plugging in the lower bound, a minus, and I put in the 0, and I get a squared to the 3/2. Now I'm down here. These two negatives cancel, so I get a plus 1/3. And then, when I plug in my upper bound, I get a squared minus 0, or a squared to the 3/2, minus, when I put in the lower bound, I get a squared minus a squared. I get a 0 to the 3/2 for the lower bound. So these two negative signs cancel, giving me a 1/3 a. Those 2's cancel, giving me a cubed. And then over here, I get another 1/3 a cubed to total out to 2/3 a cubed. And that's problem number 19.